Hey guys, my name is John Deegan, and today I'm going to be going over the AAE 203 lecture from September 9th, 2025, Kinematics at Points. Now, the basic definition of a point under this context is your basic point mass. This means it has no length or depth and is kind of just sitting in a coordinate system to represent a location of mass, hence the term point mass. This is essentially a way to look at kinematics without incorporating rotation, which the addition of makes everything much more complicated. And kinematics itself is just a framework we use to describe motion. Now, the first big thing we really covered were vector derivatives, starting with notation. Now, the notation is pretty simple, so I'm just going to leave it up there at the top while I talk about the thing we covered immediately after, that being how to take the derivative of dot products and cross products. Now, both follow the basic definition of multi-part derivatives. So, for example, the derivative of v dot w is going to be equal to v dot times w plus v times w dot. And in the same way, the derivative of v crossed with w is going to be equal to v dot crossed with w plus v crossed with w dot. Now, this brings us to a key concept, that being that vector derivatives are always relative to a reference frame, by which I just mean a coordinate axis. This is essentially a set of perpendicular coordinate axes used to define what is fixed, or rather what a motion is relative to. So think about your basic XYZ coordinate system and how the origin is used to define location, and by extension, any kind of motion. Now this carries us into frame derivatives, and a frame derivative is the derivative of a vector from the point of view of a specific reference frame. So for example, if we say x can be defined within the xyz plane, x of t is going to be equal to x1 in the x direction plus x2 in the y direction plus x3 in the z direction. And if we want to take the derivative of position, dx over dt, you would just take the derivative of each individual part, and that would be your answer. Now that the basics are covered, the last little headache we have to cover is switching between reference frames. Now I'm going to throw up this in 2 dimensions because in 3 dimensions it's a lot harder to wrap your head around. So let's just say you have a coordinate system of A and B, but you want to put it relative to your X and Y frame. So to make this switch, the most intuitive way to go about it is to project the reference frames on top of each other. Then, using the knowledge that each reference frame must have an angle of 90 degrees between each of their respective axes, angles can be drawn can be drawn to relate the movement of points within one frame to how they would move relative to the other. Thank you for watching. That's all I have.